So the first theorem has to deal with a perpendicular from a center and a chord. So it reads as follows. The line drawn from the center of a circle perpendicular to a chord bisects the chord. So what are we basically talking about? We are talking about a chord AB. You can see that's AB, right? It's a chord. We can see it's a chord. We know what is a chord now, right? They say that if you draw a line from a center, right, if it's perpendicular to this chord, it'll definitely bisect the chord, right? So let's prove this and see if we understand it and understand this. So we are given a circle with a center O, as you can see on the right hand side, and a chord AB with OP that is perpendicular to AB, right? So what do we have to prove? We basically have to prove that AB is equals to PB. That is all that we have to do. So let's look at the proof. So the first thing that will draw your attention is that we are going to use radius, right? So we're going to draw a radius from 0 or point O to A, and another radius from point O to B. We know that their radius will be the same because remember, if I draw any radius from a center to any part of the circle, it is exactly the same. OB, it is the same as OA. If I call this Q, it will also be the same because it's a radius, right? So let's move on. So the first thing that we're going to do is we are going to use triangles, right? If you can see closely that I have triangle OPA and triangle OB or OPB, right? So we are going to use what we call congruence. This is what we learned in grade 8 and grade 9. So the first thing that we're going to do, remember with congruence, it is important that you remember congruence. You have to follow a pattern. So we're going to talk about it now. So as I've written it like this, you can see that what we learned in grade 8 and 9 is that the way I wrote it, triangle OPA, the way I named my triangle, I start at O, then I go to P, then I go to A. When I name the other triangle, I must also start from O, go to P, and then go to B. Already you can see there's a pattern, right? So if I choose OA, so what I'm basically teaching you now, it's basically grade 8 work and grade 9 work. OA, in this pattern, I must also go OB, right? So what does it tell me about OA and OB? In that pattern, from OA and OB, what do you notice about these? I can see that OA and OB are ready. They are the same. They are both radius, right? So that we say they are ready. So it's a statement that I've just said here. And it's my reason. Exactly how we did it in grade 8 and grade 9. All right. The next pattern that I need to look for is OP. So I'm looking at OP. Again, I'm going to also look at OP. So as I name it, the same pattern that I see in this triangle, I must also see in the other triangle. So what can you tell me about OP? OP is shared by both triangles. So OP, we can say it's a common side. So this is my statement, and this is my reason. You can just say common. So what we used to do in grade 8 and 9, we used to say statement, we used to write statement, and we used to write reason here. That's what we used to do, right? Okay, my spelling there is bad. Reason, right? So we need the third part, remember. So what is the third part? OPA and OPB. These are angles. So what are we talking about? Another pattern is P. That's P. What can you say about P? It's an angle OPA, meaning I'm talking about this angle, and triangle OPB. They are both 90 degrees. Because remember that we were told that it is perpendicular. The line drawn from the center, it is perpendicular to that chord. So because both of them have 90 degrees, what have you proven? You have proven that OP is perpendicular to A. So you are given this one. So 90 degrees, right? So that's your reason. And so that's your statement, and this is your reason, right? So what have you proven? You have proven something that is very, very important. You've proven that this side is equals to this side. You've proven that this side is shared by both, and you've proven a right angle. So what have you proven? You've proven right angle, the hypotenuse side, and a side. So you've used this proof that right angle, the hypotenuse side, and a side. So you can say these are congruent now, right? They are congruent. Therefore, triangle OPA is congruent to OPB. Please do not mistake this as similarity. Remember, similar triangles use that sign. Therefore, you can say that AP is equals to PB. So what am I basically saying? I'm saying if this side is equals to this side, and if this side is equals to this side, then because it's a triangle, this side will definitely need to be equal to that side. That's the third side of a triangle. Simple as that, right? So we have proven this. The next thing that we need to do is apply this, right? So we're going to apply this using example, and we're given that we have a triangle OQP, right? They want us to calculate X. We are given 4, and we are also given that PR is equals to 6 centimeter. Already we know that using theorem 1, which states that a line drawn from the center that is perpendicular to a chord will bisect the two sides. This means PQ will be 3 and QR will also be 3, since PR is 6 centimeter. That's it, right? So you say, once you make your statement, your reason will be perpendicular from a center. So that's your reason, right? So because we're in grade 11, remember that's what we used in grade 9 and grade 8. So PQ equals to PR is equals to, it is equals to 3 centimeter. PQ is equals to PR, which is equals to 3 centimeter. And your reason will be perpendicular from a center. That's it, right? Now that we have 3 and we have 4, we can use Pythagoras theorem, which states that PQ squared plus OQ squared is equals to X squared, right? That's the hypotenuse side. So when we solve, we know that PQ is 3, OQ is 4. We solve, we get 9, and we get 12. When we solve for X, we will get 5. Simple as that. That is how we apply this formula or this theorem. Simple as that. Okay, guys, any questions after watching this video, leave it in your comments, then we can discuss it. Thank you so much.